Süper, hoş geldiniz. Ee, Ben Şükrü, OBEA'nın kurucu ortaklarından, teknik ekibin lideriyim. Hoş geldiniz tekrardan. Ee, OBEA olarak güzel bir etkinlik serisine başladığımızı düşünüyoruz. Mühendislik yönetimi serisi. Tamamen mühendislik yöneticilerine, takım liderlerine, CEO, CTO'lara yönelik bir seri olmasını planlıyoruz. Bugün de çok değerli katılımcılarımız var. Sonar Global ekibi bizimle. Sonar Cube'u tüm yazılımcılar biliyordur. Herkes ücretsiz olarak başlamıştır, projelerine eklemiştir diye düşünüyorum. Çok güzel gelişmeler var o tarafta da. Çünkü kalite bulgularını, yapay zeka ajanlarının gelişmesiyle beraber daha hızlı fixleme yollarını gösteriyorlar bize. Biz OBE olarak da Sonar'ı ilk günden itibaren çok verimli kullandığımızı ve firmalara promote ettiğimizi düşünüyoruz. Umarım siz de kullanıyorsunuz. Kullanmıyorsanız mutlaka bakın. Böyle bir etkinlikte buluşmak bizim için çok zevkli. Bugün aramızda dediğim gibi Etiya'dan Tuğçe Hanım, Intertek'ten Özgür Bey, LCV2'den Utku Bey, Albaraka'dan Sadık Devran Bey ve Turkcell'den Abdullah Bey olacak. Çok değerli konuşmalar olacak. Ben şöyle söyleyeyim, kaçıranlar üzülsün yani. Şimdi ilk konuşmayı e, Sonar ekibinden Rafi'ye vereceğim ama öncesinde Sonar Global'den Tarık'ı sizi selamlaması için sahneye davet ediyorum. I would like to invite Tarık to welcome everyone. Okay, please Tarık, welcome.
Yeah, تشكرا شكرا. Hello everyone. مرحبا. These are the only few words I know in Turkish. Last time I promised I'll add one more word, which was today مرحبا. So welcome everyone to the joint event that we're doing with OBEA. The team is here, the global team is here. By way of introductions, my name is Tariq Khalil. I'm the VP for EMEA South, based out of Dubai, covering the whole region. So we've committed earlier that the visits to Istanbul, to Turkey, to other countries that we are covering will be invested in. And this is exactly what we're going to demonstrate today, not only from a team's perspective, engaging with customers and clients, understanding their needs, but how have we progressed since our probably past 2 years on getting the right requirements and translating them specifically in the AI area into products and functionalities. So Rafik is joining us today during this trip. He's our expert on the technicalities of Sonar's platforms, evolving from a single product into an end-to-end platform, covering the different aspects of what we are calling ACDC, Agentic Code-Centric Development Cycle. And this is what we'll be focusing on today. We've announced earlier last week the acquisition of Guitar, which we refer to today as well. We are introducing part of the expanded platform of ours, the Sonar Cube remediation engine. It's all AI related, and this is the paradigm shift that we're seeing and the way the market is trending, specifically on the development cycles. We're enriching our capabilities into the security aspects of the ACDC as well, and this will be demonstrated today. And we're always here to support, bring the right level of expertise, the right level of know-how, in conjunction with our partners, OBEA, and the market. So with this, without any further ado, I think it's better if we demonstrate to you what we're doing by Rafik, my colleague Rafik. Just to also mention, Amir on the team as well is managing the territory, Turkey and South Africa. And whatever needed to be present among us with the partners, he's always available. Yeah, and he's a Turkish, native Turkish speaker actually. Thank you, teşekküren.
Yapay zeka modelleri, ajanları, işte Cursor, Windsurf, Cloud Code, onlarca biliyorsunuz araç, anti-gravity hem de modeller çıktı. Şimdi Sonar Cube baştan beri statik kod analizi yaparken şimdi bunu bir seviye daha taşıdı. Yapay zeka ile beraber modellerin hem biz verimliliğine uğraşıyoruz biliyorsunuz. Yazılım kod kalitesinin verimliliği, geliştirici verimliliğine uğraşıyoruz. Sonar da burada yapay zeka çağında hani güvenlik perspektifine nasıl yaklaşıyor onu da dinlemek isteriz. Sözü ben Rafi'ye veriyorum. İyi seyirler şimdi.
Okay, thank you very much. Let me add my second screen, add window. There we go. Nice, thank you very much. Thank you very much all for being here today. I'll be talking today about coding in the age of AI agents. So I'll be covering first why AI coding matters, and then we'll go into the best way or the best workflow to secure a reliable agentic coding workflow. In addition to looking a little bit on the future and talking about how the world is going into the autonomous AI agent and remediation. Before I start, I would like to talk a little bit about Sonar for those who doesn't know the company. We've been in looking after quality and software security for the last 20 years, mainly reviewing the code that is written by developers and DevOps team. And actually, we are going in the direction to provide the same capabilities and required capability for the agentic worlds within the same pattern deterministic way. And we'll explain this in detail. So first of all, like having AI coding agent is an emerging technology that enable business to go fast, to access to the market. It's come with a huge opportunity. The same way that we had internet and web application, mobile application, beginning of the years 2000. This is something that enable a lot of business. But on the other side, it will be coming with a lot of challenges. And one of the challenges that we are seeing on the market, actually, that when you start working on AI systems, you start like building stuff either for yourself or for your team, whatever it's like your development team. You are also doing it for the like on the department level, on the business unit level, and usually it's like small application, less than 50K lines of code. It's have a short life. It means like few months, and then you will create a new application or you use a new application. And usually you have like limited access of users, and those users they are friendly because either they are your colleague or other department that you are working on it internally. When you move from that side into going into enterprise mission critical application, which is usually more than 500K line of code, the application is there to live and still because you are building your core businesses and you are building the value that you are delivering to your customer, and you have more aggressive end user because you have the end user, maybe a customer. If today they are not happy about your software or mobile application, they will move to another bank. So we are seeing actually that there is a gap. And that gap we'll be seeing because the agent default quality level is low whenever you are writing like an application for yourself or for a big company. And here, the job of Sonar is to go and close that gap. So actually, we are building the same patterns that we've been building for developer for the agentic world to deliver whatever code is written by a developer, assisted by AI or fully written by AI. We close that gap in terms of quality and security. If you are not doing that and you are not reviewing, you will end up in some of these cases. For example, here I put a couple of examples of where AI code was like disasters in terms of use. For example, Amazon, they've been delaying 6.5 million orders because they've been deploying some code that's been written 100% by agent, not reviewed by a human. They reverted back to 90 days. And also, they put a human in loop because that's one of the aspects of not taking the quality and security of AI-generated code seriously. We have a second example from Pocket.OS where there is an agent that's been fixing an issue, and he dropped a full database, and it leads to 3 days of outage for that specific platform. So it's a serious problem, and it will become more serious when we start introducing AI agent and AI coded assistant in more business critical platforms. So why this is happening? And that's a good question because we are building models to perform. We are building models to deliver like better than a human. But actually, all that code is usually trained on human generated data, whatever it's like source code, best practices, documentation, etc. And we know actually that human make mistake by default. That's why we are training on not very bad quality, but there is a chunk of bad quality that introduced in LLMs. So we've been benchmarking the top-rated LLMs on more than 4,000 Java problem, starting from like very easy problem to complex one. And we measure code complexity. We measure as well the security and the vulnerability of the written code, whatever it's like just introducing vulnerability through third-party libraries or write like a vulnerable code. We've been measuring also the bugs that is introduced in terms of reliability and maintainability. And finally, also the architecture of that code. Is that code maintainable in the future? Today, it's 50K lines of code. It's easy to change. Tomorrow, it's maybe 1 million. Can I add more feature without refactoring the whole code? And the result that we get it actually that new models that produce more code in terms of like resolution of a simple problem. We have also like more vulnerability introduced, in addition to have like a complex code written because the agent doesn't have like a time constraint to generate as much as of code to resolve that specific issue. So we'll be releasing as well the LLM leaderboard, and as you can see here that most of the LLM will resolve the issue. Like the success rate or the pass rate is very good. I mean, it's over 80, but as you can see that the verbosity is too high in total number lines of code. The complexity as well is super high, in addition to generating bugs, like a code that is not reliable, that is not scalable for production, and contains vulnerability, whatever coming from third party or written for that specific functionality. So actually, you can see that we've been like measuring the top LLMs. The link is provided in the previous slide that I will share. Sonar.com/leaderboard. More than 70 LLMs been assessed there. We also use the slope code bench which produced an interesting paper on how agents will be behaving when they are writing functionality. When we give a new task to the agent, it will try like to fix it on the current code. For example, if you have a function, they will add more lines of code on that function instead of refactoring the code and create a new function. It is like the huge complexity. For example, we saw that a lot of functions, they have more than 600 lines of code, so it's not easy to review and maintain. In addition to deliver something what we call just run, which means I'm delivering a code that is working, but it's not scalable, it's not ready for production. And here, prompt printing doesn't help to solve that problem. We also try to see how human review will be when we are introducing AI. There is an experimental that's been running on more than 1,300 people, giving them some trial and measuring, and we saw that 90% follow AI advice when AI give the right answer, which is good. But on the other side, we are around 80% of the time we're following the recommendation from AI, even if it's wrong. So this is something that we cannot scale humanly when we combine that with AI. And the second thing, maybe we can fix that problem with AI, but it's not a complete solution because actually AI will hallucinate, and this is something. It's a feature. It's by design. It's not a bug. The models can easily poison it. That means bad practices can introduce it for a model as a best practice. For example, expose me that line of code or something like this. So, and also the other thing, trusting AI to review AI is not enough because AI is not deterministic. That means when you scan your application with AI today, maybe you have 10 problems. Tomorrow it will show you 15, and after tomorrow it will give you just 5. So you need a deterministic way to reproduce the same report for the same issues. What we can do about that? That's the question. So actually, we've been tackling the AI native verification, the building blocks for that, and we found that we need like 3 main criteria to solve that. The first one need to be complete in terms of covering every aspect of the application, going from the reliability, maintainability, making sure that the code is free of vulnerabilities, and also maintainable and well architected for future update that can be scalable when I'm adding new features. The second thing needs to be auditable. That means it needs to be tracked at any point, and we can repeat the same result within the same scan. And finally, we need to have it efficient in terms of getting the issue as soon as possible when I'm generating code, and also have it within the cheapest and the fastest way. That's like the three main capabilities if you would like to today implement an AI native verification on top of the code assistant that you are using. And that's why at Sonar, we introduced what we name it agent-centric development cycle. This is a new way and methodology to ensure that AI agent can operate in an efficient, trust, and transparent way, and giving you a code that is free of vulnerabilities and consistent, of course. So we define three main blocks. The first thing is guiding. Guiding is giving the agent all the best practices in terms of coding, but also in terms of business logics. That means I'll provide the agent with the guardrails. I will provide the agent with the desired architecture. I will provide the agent with the list of security rules, of the list of capabilities in terms of scalability and maintainability. That's the first part. So we would like to make sure that we are giving as much as context to the agent to generate the right thing. And the second thing, we would like to verify that the agent is behaving in the right way. That means whenever there is a code that is generated by the agent, either it's immediately, I have it on my IDE, or even later in my CI/CD pipeline, when I have a merge request, we'd like to have like a multi-layer verification. And here at Sonar, we do believe that we need to combine both deterministic and deterministic way. In terms of having the deterministic way, actually we have more than 8,000 rules that is covering 35 languages. And also we are introducing a hunting agent that will be able today to discover a new issue in an undeterministic way, and then generating some rules based on that. And the last thing, because we know that we'll have some issues in our application, so the idea is to have an automated way to fix issues, especially on the technical depth, but also on the scalability and the speed that the AI will be generating those fixes, those codes. So here we have like two loops. The first one is the inner loop, which is guiding and verifying when I'm developing. And the second one is the outer loop, which is running on your CI/CD pipeline when the job is finishing. I would like to scan my code and make sure that I'm compliant with all the recommendations and the best practices in terms of maintainability, reliability, and security. We've been testing this as well. So actually, we take the same code slop bench. We try to see like the complexity of the code generated based on just no guidance. That's the blue line that you can see that the complexity and the checkpoint is going up. Then the second one, we are just giving the context to the agent. And you can see that the performance is enhanced. And the third one, because we are introducing also the AI code fix, then you can see that we are able to have like a good quality on generated code. So that's the full loop guide, verify, solve, that will help you actually to have a checkpoint on each step on your development lifecycle, and then be able to implement it in a fast and cheapest way. How we can implement it now? So we can implement it because we are giving those capabilities for you. So we have a zero trust multi-layer approach that is auditable. That means that you can have the reports based on application, based on branch. It's also explainable. So we give the explanation to the developer or to the agent why we think that's an issue. And based on that, we have either to fix it manually, or in some cases, I will explain why we are not covering 100% of AI code fix. Then you can use an agent to fix it. In addition to be repeatable, that means the same application that I'm scanning today, it gives me the same result tomorrow. And also accurate with a less rate of false positive, because raising like thousands of issues, that it doesn't make sense for the developer. And we've been releasing, for example, recently what we called agentic coding rules. That means we know if you know that 100% of your code is written by an agent, we don't need, for example, to take care about like the look and feel of the lines and stuff like this. We are removing all these rules because we know it's just a look and feel. It's for human to read the code, but the agent doesn't. It doesn't matter for you. The second thing, because we are covering, as I mentioned, more than 40 languages, including like all languages using in banking and insurance and telecom, whatever it's SAP, ABAP, whatever it's COBOL and so on. We are deeply integrated on the developer workflow, and this is like very different from the existing tool in the market. That means actually you can start verifying at the first step whenever it's on your IDE or even like plugging Sonar with AI code assistant like Claude, Cursor, etc. And also making sure that you have an architecture overview what's been delineated and compare it to the desired architecture, in addition to providing AI coding tools like the MCP that I will show, the CLI, the hooks, and the integration. So we're putting that in a different steps of the life cycle. It's starting from the developer IDE when the developer will be prompting here. Then there is the code generation. We verify using the context segmentation, using also the agentic analysis via MCP, CLI, or even plugins for the IDE. And then based on that, because we know that actually there is a quality gate when you are merging, we combine this with the remediation agent, with the code review, and also with autonomous review that I will show it using our new acquisition for Guitar. So actually we are combining this. So we are giving the developer the power to fix it at the source in near real time. Plus, we are giving also the capability to the technical leader of the DevOps team to review that on the fly and either push back or fix it by themselves. So the blueprint for that, the first thing is to enable any integration, for example, using the CLI or using the MCP, also using the Sonar Cube IDE from the marketplace, whatever an IDE they are using. The second thing is to provide the best practices for your AI code assistant, documenting example, using skills to encapsulate that, and using hooks, etc. And the third part is monitoring the result and seeing the quality of the generated code and like giving a feedback to the agent in order to be able to generate more safe and reliable code. That's like the blueprint, like on 3 steps. Within that said, let me just switch here and show you some example in action, because this is like, I think it's the most important. First thing, as I mentioned, you have here access to our LLM leaderboard for code quality and security. You can see that the list of the problems that we are generating, and you can compare the different AI code assistant or LLM models designed for coding. We are here like assessing more than 70 of them. You can also use that to compare. If you are like a little bit of doubt between 2 models, you can select 2 models and see how those 2 models behave. For example, here I can compare 2 models, and you can see the result. And based on that, and depending on the different criteria that it makes sense for your business, you can choose the best LLM for you. So let me first show you one of the examples that we are using AI Code Fix. I've been mentioning that actually we have the AI code fix that is running on the platform, but we are not covering those 8,000 rules that we have here. And the reason for that, there is like two main reasons. The first thing, there is like simple problems when you don't need AI to fix it. I mean, if you'd like, for example, here you have this 8,000. Actually, we are covering around 4,500. And the first reason, because sometimes the problem is so easy, you don't have to like to send it to an LLM. And the second thing, we are only enabling LLM code fix when we know that the LLM will provide a valid response with 100% or 99%. So here I have this issue. It's a SQL injection. Sonar explaining what is the issue, why this is an issue, how can I fix it? That's the let's say the traditional way. And here we have the generate AI fix. As a developer, maybe I'm not a security expert, so actually I'll be using the AI. Here you can see that I have my old code, I have my new code. The new code will be also scanned by Sonar. So here I'm pretty sure that I'm not introducing a new vulnerability. And based on that, I can go directly here and switch to my IDE. And when I'm switching to my IDE, I will have the old code there, the new code I can review it, and then I can either apply or decline. This is something that is really important because you are giving the power to the developer to fix it directly at the source. And the other thing that I can also generate that issue directly from the ID here. So if I open one of my issue and they are eligible for AI code fix, I can do the same. I can come here, I can generate an AI fix, and from there it will take me to that specific file here, and then navigate to that specific line. And here you can see, and I'm adding just a try-catch exception on a Java application. So this is something really useful for the developer experience because it will help him to fix the issue at the source. So I have the list of the issue that is related to my file. Of course, here I can configure my ID to say, just give me the list of the issue that is related to the file that is opened, no, or all the files. So depending on my preference. And then based on that, I can fix the issue directly using the AI code fix. The second thing that we have, actually, if I move back to my presentation here, the second thing that we can enable the remediation agent part of my CI/CD pipeline. That means I have a new pull request that is coming to my CI/CD pipeline. You can see that the quality gate from Sonar is failing. Here I have like the maintainability score should be A, but it's B. And there I have the SonarQube agent, the remediation agent that will be plugged there. And what's happening, it will take the input from the quality gate. It will take also the file that's been changed. And then it will try to provide a fix for each of this issue. For example, here, I can see based on that, I have 3 issues. And then here, the agent will provide a suggestion for each of these issues. As a tech lead, I don't have to push back to the developer. That means here, the SonarQube agent will tell me what is the issue, what is the type of the issue. For this case, it's maintainability, the severity, and also how much time it will take me to fix it. It's 5 minutes because I'm introducing just a new new argument. So this is something that you can combine it with the AI code fix. At the backend, it's the same service. So we are trying to put at the right place and then help the teams to move fast. The other thing that you can put in place is the MCP server. This is something that it can talk directly to your AI code assistant whenever you are using Claude Code, Cursor, Copilot, etc. It will sit in the middle, and whenever there is a code that is generated by those code assistant, it will see if that code it's aligned with the list of the quality profiles, the rules that I'm providing, whatever I'm running my SonarQube server on-prem or on the cloud, and based on that, I will give a direct feedback to my developer. So this is something really useful because it will even prevent you to have like the code in the IDE like Heath. Whenever I'm using an AI code assistant, it will be revisited on the fly based on the list of the rules that I'm defining, and then be able to provide recommendation. So actually, we support most of like the top code assistant, including Claude Code, Anti-Gravity, Codex, and so on, and we can integrate for any custom need if that's mandatory for you. If you're using a custom LLM, that's something that we can help you to integrate. The second thing that I would like to show you is the ability to have the agent working on the technical dev. And this is like something really important because usually, for example, here you can see on this project, I have more than 10,000 issues that can cost me like more than 3 years to be fixed. So it's like a huge effort. And we've been introducing recently the AI code assistant or the remediation agent directly on the platform. So here you can filter, for example, which problems that are fixed by the agent. You can see here that I'll be filtering. I see all the problems that are fixed by the agent. And based on that, I can come here and assign one issue to that agent. This is something we can do on the issue, but also we can do as well on the dependency risk. That means if I have a dependency risk that is here, I can also say, please fix me this dependency risk, the agent, and I can still like working on my business logic and come back and fix that later. So you can see here that it will go to the agent activity. You will see that there is a couple of issues that are running there. Once that's done, let me show you one example. Once that's done, you will get the pull request here that you can open, and you can see that the agent was taking that specific issue and providing a fix and then scanning again using Sonar. Here you can see that here what I've been doing, I've been changing this and adding a request method to get, just to make sure that I cannot play with the HTTP request. This is my merge request presented by the agent. So I was like removing this line and reducing that one. If I go back here, you can see that once that's done by the Sonar Cube remediation agent, we have also the ability here to either like have an auto approval or just having a human in the loop. And it's the same if I go for the vulnerability. I'll give you one example for the vulnerability. It's the same for the vulnerability here. So I have a vulnerability. This is my library. This is the vulnerability that I've been impacted by. The agent will be changing two files here, reading two files and changing one of them. And you can see here that we are removing the old version and we are putting the new version that is suggested by Sonar, which a huge add-on for the team, especially on legacy application when you have like a lot of application that is legacy, that is holding like the business logic, and you don't have the time for that specific issue, because it will take you like maybe here more than 1,000 days to be fixed. In that case, you can associate this issue to the agent, and then when you have time, you just have to review and accept that specific suggestion from the agent. One last thing that I would like to show to you is, and I'll talk about, is the acquisition of our new guitar, which is an autonomous AI agent. This is something that it will help you actually, if I will show you an example, it will help you actually to go and review one pull request in an autonomous way. That means we are not detecting the issue with Sonar and then having the agent going and fixing those issues. The agent will review the full request. Here we have 12 files. He will be going files by files, finding the issue. For example, here saying I find a bug, then he will be discussing with the developer, is that needed? So the developer here give the feedback, and then the agent thank him for the explanation and continue working on that. And by the end, when everything is done, you can see here that I will have all the issue that been resolved, 16 out of 16. I'm exposing here all the list of the issue. I can also do some auto apply, if that makes sense. If I've been using the agent for a while and trust him. And finally, I can merge this in my pull request. So this is how the world of like review in the age of AI going, because actually with millions of lines of code generated by AI on daily basis, there is no way that you can do it manually. You have to do it at scale in an autonomous way with the less noise for developers and DevOps team. Okay, we go through. Okay. So why we are more successful with AI? Because first, we have less 44 lives likely to report outage due to AI coding when you are applying the rules that are provided by Sonar. And the second thing, because we are optimizing the way that we are using AI based on our expertise for the last 20 years, you are using and burning less token than trying to solve the issue using any AI code assistant. So our recent study demonstrates, for example, that we are using 7% fewer inputs tokens. Also, we are reducing the agent reasoning effort by 11%, which is a huge at scale. So just to recap the agent-centric development, actually we have like the three main blocks. The guide we provide the Sonar context segmentation, providing the agent with the context, plus the architecture. In addition, that's something I haven't got the time to show to you, but just ping me after the presentation. In addition, also to the verify part, which is coming with the Sonar agent analytics, AI code review, and also the advanced security. And on the solve side, we have both the AI code fix and the remediation agent. Yes, and finally, I would like just to announce that this is actually what I show is provided on our SaaS platform, and then the remediation will be available on server, because I think this is something makes sense for a lot of customers in Turkey, starting from July, being a part of the version 2026.4. I think that's all from my side today. Thank you very much. Yes, just reach me to me, Tarek Emir, and yeah, we are happy to discuss with you. would like to download the slides, and then you can book a demo as well. Thank you very much, all.
Thank you, Rafik, for this great presentation. If you would like to ask any question to Rafik is here at the end of this event. Please feel free to ask in the lunch, okay?
Thank you very much.
Thank you. Sorunuz varsa etkinlik sonuna kadar Rafik burada. İstediğiniz zaman sorabilirsiniz.